So let's solve a practice question here. We have a basis S, and this is the basis of our complex vector space of 3 dimension. Okay, so 3 vectors are given there in the basis, alpha, beta and gamma, and the field of the vector space is C, and we need to show that S dash, that is a set of vectors alpha plus beta, beta plus gamma, and gamma plus alpha, is also a basis of C3. Okay, so let's see what we can find from the information that is given. So S is the basis of C3. It means that all the elements of S are from C3 itself. Okay, so if S is the basis of C3, then alpha, beta and gamma are elements of C3. Okay, so and we know that it is given that C3 is a vector space over field C, so the closure properties should be satisfied. So it should be closed with respect to the operation addition. It means that we can say that alpha plus beta, beta plus gamma and gamma plus alpha will also be there in C3, because alpha, beta and gamma, all these 3 vectors are there in C3, so alpha plus beta, beta plus gamma and gamma plus alpha will also be there in C3, right? Okay, now we need to show that these vectors here are linearly independent. If we can show this, then we can say that S dash is also a basis of C3. Okay, so let's see. To show that these 3 vectors are linearly independent, we need to show that this equation C1 into alpha plus beta plus C2 into beta plus gamma plus C3 into gamma plus alpha is equals to 0 only when C1 equals to C2 equals to C3 equals to 0. And these C1, C2 and C3 are the elements from the field C. Right? So let's solve it. So this, we can expand it like this, and then we can recollect all the alphas, that is this alpha here and this alpha here, and we can write it like this. Then similar thing we can do with beta. So this beta here and this beta here, they will club together, and then we can similar thing we can do with gamma. This gamma here, we can club together. So what is this? This is the equation, that is some constant, say k1, k2 and k3 equals to 0. Okay, k1 into alpha, k2 into beta, k3 into gamma is equals to 0. But we know that alpha, beta and gamma are linearly independent because they are the elements of basis S. So we can say that this can only be true when we have k1, k2 and k3. k1 equals to k2 equals to k3 equals to 0. This can only be true when these scalars are 0. Okay, so what does it mean? It means that our k1, that is c1 plus c2 equals to 0, k2, that is c1 plus c2 equals to 0, and k3, that is c2 plus c3 equals to 0. Let's suppose this is the equation 2 and this is equation 1, and we are subtracting equation 2 from equation 1, then we can get C3 minus C2 equals to 0, right? And this further means that C3 equals to C2. And when we put this in this equation particularly, then we get 2C3 equals to 0. And if C3 is equals to C2 and C3 equals to 0, then obviously C2 will be equals to 0. And from equation 2, we can say that when C2 equals to 0, then C1 equals to 0. So we got C1 equals to 0, C2 equals to 0, and C3 equals to 0. And this is the only solution. So we got only solution, that is C1 equals to 0, C2 equals to 0, and C3 equals to 0. Right? So now we can say that this equation here, we started from there. This equation here is only true when C1 equals to C2 equals to C3 equals to 0. Right? It means that this vector here, this vector here, this vector here, they are linearly independent. And what does it mean? It means that our S dash is a basis of C3. Right? So this was it. I hope you got it clearly. Thank you for watching. Bye.